on this computer and we will just jump into things here. I'm going to talk about multiplying fractions. So you guys can go ahead and copy that title down. And you can also copy down some of the examples. And while you are doing that, I think I will, let's see here. Pause my recording. All right, so the good news is when it comes to working with fractions and getting into the point where we're now multiplying them, is that life is easier than it is with adding and subtracting, okay? So if you've copied down these examples, so I had a chance to pause the recording there. The basic concept of multiplying fractions, if you look at example number 1 here, is that you just multiply straight across, okay? So listen to how I do this. One time, I take my numerators and multiply them straight across. 1 times 3 is 3, and that goes over. 2 times 5 is 10. And that last question you always ask is, can I reduce? Okay. So right off the bat, you should be thinking, boy, that's a whole lot less steps than dividing and subtracting fractions and borrowing. So that's the very basic level. I'll give you another example. Number 2, I'm looking at that. There's nothing I can cross cancel, which we'll talk about in a moment. 2 times 4 is 8. Multiply the numerators. 5 times 3 is 15. Multiply the denominators. And there's my answer. Last question, can that reduce? No. All right. And again, I bet you could do number 3 here. So take about 5 seconds, do number 3 here. All right, you should have gotten an answer that looks something like this. Okay, so that's the basic, at the easiest level, concept of multiplying fractions is you multiply straight across. All right, we're going to jump up to something a little bit more complex, which is multiplying more than just 2 fractions. In this case, we have 3. Okay, but in these particular examples, it's the same idea. But listen carefully how I do this. I do 3 times 1 is 3. I take that answer, when I multiply these 2 together, it's 3. Take that answer and multiply it by 3 over here. So this becomes 9, okay? Listen carefully again. I'll say the same process down here with these denominators. 5 times 2 is 10. I'm taking that answer, that 10, I'll write it right down here, okay? Okay, and multiplying that times 4, if I wrote it down here, and that gives me 40. Last question, will this reduce? No. Okay. You can go ahead and I'll give you 5 seconds to do number 5. Okay. Hopefully I gave you enough time to go. 3 times 7 is 21 times 3. And if you did the math down here, 3 and a 6, you get 63. Okay. So that's the basic level of multiplying fractions. Way easier. Okay. But we're going to take it up a notch or 2 because there's definitely some slightly different occasions. Like, for instance, what do you do if you get a story problem like this? Okay. If an owner of a 5/6 acre parcel of land, that parcel means piece or section of land, plans to sell 1/3 of the land, how large is the parcel that he plans to sell? All right, so I'm going to tell you a little secret word here that has so much of the time to do with multiplication. In a story problem, this word of, okay, very often the word of here, you might want to write this down in your notes, okay? In fact, you can write it just like this, equals times. Very often, not always, but very often in a story. If I say, what's 2/3 of 90, for instance, if I said, I'll just write this out, 2/3 as an example, okay, I'll write example here for it, okay? And I wrote the phrase, can you tell me what 2/3 of 90 is? Okay. If I ask you that, this word of, okay, I'm just going to draw a little arrow to it, means times. So what you would do is I would go like this: 90 over 1 times 2/3. And if I did my math real fast, 3 goes into 90, what, 30 times? 369, so 30 times. So I get 30 times 2 is 60 over 1, which is 60. Okay, so that's 2/3 of 90. All right. So just so you know, very often when you see the word of, okay, so look at my question is: an acre of land plans to sell 1/3 of the land. See this word of here, okay? How large is this parcel of land? It's 1/3 of. Well, the land that this person's selling is how much? It's 5/6 of an acre here, okay? So essentially, it's asking you, what's 1/3 of 5/6? Okay. And 1/3 of 5/6 would be, like I said, take your land. This is how much land there is times 1/3. And you would get, nothing can cross cancel here. So I'm going to get a 5 over 18. And I'll ask, can I reduce that? No. So how much of this parcel is he planning to sell? 5/18 of it. Okay, this should be my answer. Okay, so that's an example of a story problem at that kind of simpler level. Okay, now I'd like you to take a moment and copy what you see on the screen, and then I will jump in and continue with that in just a moment. Okay, hopefully I've given you time to copy this down. This concept of canceling, all right, and some of you may remember way back in the day when we started canceling fractions, I got lost, and why do they add that in there? And that seems complicated. It made it harder, and I wish they hadn't done that. Okay, if that's your memory of canceling, I'm going to tell you why actually you missed out on a big friend, a really good friend that could have helped you out a lot in math, and I'm going to show you why real fast here. Okay. In essence, what canceling is doing is reducing before you multiply, so that when you get to your answer, you don't spend 10 minutes trying to reduce some two big numbers. Okay. Let me show you an example. If you look at number 4 here, okay, if I didn't cross cancel and I just multiplied straight across, here's your scenario. You're taking an exam for a math class. You're in a hurry. You're kind of stressed. And it says right in the directions, reduce all answers to lowest terms. So you multiply 21 times 13 without doing any canceling, and you get 200 down here. You get this 273 at the bottom of the screen here. And you multiply 26 times 28, you get 728. And you're in a hurry on your test or your homework. And you think to yourself, can I reduce 273 over 728? And honestly, you have no idea. But you have a sneaking suspicion that there might be something like 3 or 8 or something that, or 9 that might go into both of these. Okay. But you're not really sure. And so it could take you a long time to figure out, can I reduce this by starting to divide various numbers? Or even at number 5 here, 7 times 9, 63 times 5, you get a big number over a bigger number. And can I reduce that? So can you see right away that it could be really stressful to try to figure out how to reduce big numbers, big fractions? Okay. Enters the room, walks into the room, a new friend. Okay. And that new friend is this thing called canceling. Okay. And I'm going to show you why Mr. Canceling, we'll call him here, is your buddy. Okay. Because watch what happens here. I'll take a simpler example, number 1 here. I'm looking at 2 times 3 is 6 over 20 and 6 over 20. Those are both even. I would have to reduce. Here's what canceling looks like. Listen carefully. You may cancel any number on top with any number on bottom. So that means you could cancel 2 with 4 because, now listen to why, because 2 goes into the top one here, goes into 2 one time, excuse me, and 2 goes into 4 twice. Okay. It's just as if I wrote on the board, can you reduce 2 over 4? And you go, oh yeah, well, 2 goes into itself once and then 4 twice. You see how I got the same thing? I have 1/2 here. Okay. So I'm going to look, can I cancel anything else? A number on top with a number on bottom. Nothing divides into these. Nothing reduces these. So if I multiply straight across, I get 3 over 10, which is the reduced version of 6 over 20. okay? Now, in that case, you could have just done 620 and then reduced it down pretty quickly. Not a big problem. But as you can see over here, and in many of the problems we're going to see, it's your friend, okay? Well, look at number 2 here, okay? Again, listen to me think out loud here. I know when I cross cancel, I can reduce any number on top. I can cancel it with any number on bottom. So if I had 3 over 9 over here, I could go 1 over 3. I could cancel that down to 1/3. In this case, the only numbers that you can divide something into both is 3 goes into itself once and 3 goes into 9 3 times. 4 and 7 do not cross cancel because nothing goes into both of those. So I will multiply straight across. 4 times 1 is 4. And I will multiply straight across. 3 times 7 is 21. And I'll ask myself that final last double check. Can these reduce any? No. Okay. All right. I want you to take a moment on your own, and I want you just to do number 3 here. 10 over 21 times 14 over 25. Remember the rule. You can cancel any number on top with any number on bottom. And remember to cancel it, which means cross it out, because sometimes students get confused if they don't cross out the original number. Okay, for the sake of time, I'm looking at these, and right away, my brain, because I know my times tables, is yelling 5. 5 goes into these 2. I know that 5 goes into 10 and 25. I cancel the 10. 5 goes into it twice. Okay. And I know 5 goes into 25 5 times. Cancel it, write a 5 in its place. I look at these 2 numbers, and again, because I know my times tables, my brain just goes 7, 7. Look at 7 goes into both of those. Okay. As you learn your times tables, your brain will be thinking like that. 7 goes into 14 twice, into 21 3 times. Now I can't cancel anymore, so I'm going to multiply 2 times 2 is 4, and 3 times 5 at the bottom. 3 times 5 is 15. Can I reduce that anymore? No. Okay. I'll do, I think I'm going to jump over to number 5 here, okay, to illustrate. And by the way, if you're kind of wondering on these, 13 times 2 is 26. So this would be a 1 and this would be a 2. So look how small it got right away, okay. So that's just something just kind of get you going here as a little tip here. Now look at number 5 here though. I told you you could cancel any number on top with any number on bottom. In this case, if this number over here was a 3, let's say that the 7 was a 3, I could cancel it with 6 and go 3 goes into itself once and 3 goes into 6 twice. Just so you know, you can jump all the way over here, anything on top with anything on bottom. But right away, your brain's probably looking at these 2 numbers and thinking 7 goes into this 7 once, 7 goes into 14 twice. My brain starts thinking about these 2 numbers, and my brain starts thinking 3 goes into both these numbers. 3 goes into 6 twice and into 9 3 times. I'm double checking to see if I can cancel anything on top with anything on bottom. Doesn't look like it. So 1 times 3 is 3 times 5 is 15. I just multiplied straight across. 8 times 2 is 16 times 2 is 32. Doesn't look like I can reduce. Okay. All right. That's the concept of canceling and multiplying. You now see that it's actually the friend you wish you would have had back in the day. Okay. I want to talk a little bit about whole numbers. So you can just write this in your notes, this phrase whole numbers. We're multiplying fractions by whole numbers. And what do I do if I run into whole numbers here? Okay, what do I do? Oh, I got a 9, that's not even a fraction. And I've got an 18 over here. The solution is really simple. All you do when you're multiplying fractions with whole numbers is put the whole number over 1, just like that. You can write that in your notes, put the whole number over 1. And now it operates like a regular fraction. You've got a numerator and a denominator, okay? And so in this case, in this problem number 1 here, Hopefully by now already your brain is looking at 9 and 6 and going, oh yeah, these two cross cancel because 3 goes into 6 twice and 3 goes into 9 3 times. Nothing else cross cancels. So my answer is 15 over 2. 1 times 2 is 2. And that's improper. That is an improper fraction. I'm going to convert it. 2 goes into 15 7 times because 7 times 2 is 14. The difference between 14 and 15 is 1. And then 2 becomes my denominator. Okay. Likewise, in this case here, I'm going to cancel and go 1, 2, because 9 goes into both. I'm going to get a 10 over 1, which just equals 10. Okay. Anything over 1 equals that number. All right. So that's what we do when we multiply fractions with whole numbers. Okay. And we add canceling into that. Okay. In your notes, I want you now to add the phrase mixed numbers, this phrase right here, mixed numbers. And we got to learn how to multiply those. And once we know that, we're pretty much done with multiplying. We've covered all the types of problems. And I will give you a minute here to copy down my, to go ahead and copy down my examples, and then we'll start working with them. Okay, there's a little trick that you have to do when you're dealing with mixed fractions here. And I'm looking at this number 1 here. I've got 4.5. Okay. You should know, in fact, you might want to write yourself a little note that says cannot multiply mixed, okay, fractions. You might want to write that little note just in your, okay, you can't just multiply mixed fractions. You're saying, hey, okay, don't have to worry about it. No, you have to change them so they're no longer mixed fractions. Okay, so that little note, you cannot multiply mixed fractions. You got to change them into improper fractions. And you may recall that we talked about doing that. If I have this number 1 here, 4.5 times 5, 6, this mixed fraction, to change it to improper, I'm going to multiply 2 times 4 and get an 8, and then add the numerator. This becomes 9 over 2 times 5, 6. Okay, do you see what I did there? I brought this, I'll just draw a little arrow here. I turned this into an improper fraction, and I set it right next to my 5, 6. Now, what I can do is I can multiply. I can go, oh, yeah, I can cross cancel this. 3 goes into 6 twice, and 3 goes into 9 3 times. And I'm going to now multiply straight across and get 15 over 2 times 2 is 4. That's improper. I'm going to convert it to mixed by dividing 4 into 15 goes 3 times, because 3 times 4 is 12, 13, 14, 15. I'm going to count up 3. That's the remainder over 4. Okay. So that's what you do with a mixed fraction. Okay. I'll do one more, and then I'm going to have you try 1 or 2. Okay. Number 2 here, I look and it's a times problem. I'm multiplying. I see that I have a mixed fraction. I'm going to convert it to an improper. I'm going to say, okay, 1 times 2 is 2 plus 1 is 3 over 2 times 1/4. Okay, 1/4. In this case, there's nothing I can cross cancel, so I'm going to get 3 over 8. All right, I want you to take 20 seconds and try number 3. Remember, change that second number to improper. Then check and see if you can cross cancel. If so, do it, then multiply. Okay, I'm going to just start doing this now. I'm going to write 4/9, just the way it was, times 12, 13, 14, 15 over 4. And can I cross cancel? Oh yeah, I can cross cancel because those 4s go, you can go 4 goes into itself once, 4 goes into itself once. Can 9 and 15 cross cancel? You might have missed that, but 3 goes into both of these numbers. 3 goes into 9 3 times and into 15 5 times. Now I'm going to just multiply straight across, get a 5 over 3. I look at that, I recognize right away that's improper. So I divide 3 goes into 5 once. There's a remainder of 2 over 3. Okay, there's my answer. Okay. Now, I'm not going to actually do number 5, but I'm going to set it up for you just to so you can see what you would do in an equation like number 5 here. Okay, so you recognize right away that you've got 3 different mixed fractions. All right. And by the way, if you had a mixed fraction times a whole number, what would you do? You would change that mix to improper and then put a 1 underneath that whole number. Don't forget that. Okay. So I would go 5 times 2 is 10, 11, 12. This is 12 over 5 times 8 times 3 is 24, 25, 26, 27 over 8 times 18, 20, that becomes 25 plus 18 plus 5. 7 is 25 or 9. Okay. Then in this case, I would start cross canceling if I can. 9 times 3 is 27. These two would cross cancel. 5 and 25 would cross cancel. 8 and 12 would cross cancel because 4 goes into both of those. See how that would work? Okay. So that's cross canceling. It's your friend. It's really what you're doing is you're reducing before you multiply, as we said. And you can't multiply mixed. We talked about this. You can't multiply mixed fractions. You've got to change them into improper, then see if you can cancel and start multiplying. Okay. I hope that kind of makes sense. I'm going to jump to a story problem here. Okay. All right. Example number 2 here, sir. A paving crew, they're paving asphalt on the a street, has 7/10 of a road to pave. By June 14th, the crew hopes to complete 2/3 of it by June 6th. What length of road, this should say road here, okay. What length of road does the crew hope to finish by June 6th, okay. I want you to notice again, I've got what length of, see this word of, okay, of the road does the crew hope to finish, okay. So the total amount that they have to pave, all right, the total road, it says 7/10 of a mile. A paving crew has 7/10 of a mile to pave by June 14th. Okay. So this is their total right here. This is how much they have to do. Okay. And I'm just going to write this on here. You can do this on your test, by the way, if you have paper and pencil. And actually, sometimes you can do it with on a computer, you can add comments, but this is the total they have to do. And it says they have to complete 2/3 by, a week before June 6th here. Okay. 2/3 of it. You see that word of again? Of it. What's the it? It's this total here. Okay. So it's really saying 7/10 times 2/3. Okay. Because that's 2/3 of is times. Okay. Like we said before. That's the idea we're doing times. Okay. And then at this point, I would just do my math. Okay. So that illustrates it with a story problem. Taking the numbers, putting them on your paper. Let's take another look at another example. Marge has a shelf in her entertainment cabinet that holds 25 DVDs. If each DVD is, so she's got 25. This looks like this is probably going to be my total, but let's see, 25. I'm going to write total over here. I'm modeling for you, taking notes, okay, how we might kind of mark up a problem on a test. She's got 25. If each is 5/8 inches thick, so each one of these DVDs is 5/8 of an inch thick, how long is Marge's shelf? Okay, you got 25, and each of is 5/8 of an inch. I'm probably going to take those numbers, 25 over 1 times 5/8, and work from there. Okay, I'll end up on that one having a big numerator that I'm going to have to turn into a mixed fraction. All right, each is 5/8, and there's 25 of these 5/8, so it's 25 times 5/8. All right, So that is multiplying fractions, okay? So if you have questions, I want you to save them, and at the end here, I want you to come back and ask me if you have questions so far. I'm going to jump now, okay, to dividing fractions. So I want you to go ahead and take a moment and copy down the title and the rule that you see here. Okay, the first concept I want to give you all is this concept of something that's called a reciprocal, which you had copied down in your notes here, this concept right here. It basically means very simply the reverse of something, the flip of something, okay? I'll write the word flip in here, like you're flipping something upside down, okay? Flip it over. So if I ask you, if I had the number 1/3 and I ask you, what's the reciprocal of that? You would flip it upside down to 3/1. That is the reciprocal of 1/3, okay? In the example, 2/5. If I ask you, what's the reciprocal of 2/5, you'd flip it upside down, put a 5/2. If I ask you, what's the reciprocal of 5, you would go like this. Oh, I'm just going to put it over 1, like it's a fraction here, flip it upside down, and it's 1/5. Okay. So again, a reciprocal, or is the reverse, it's the flip. Now that becomes really important in dividing fractions, because we're going to give you a couple of examples here, okay? So what I'd like you to do is copy down number 1 here. Just take a few seconds here and copy down problem number 1. 1/2 divided by 1/8 on your notes. Now, here's the rule. When I'm dividing, okay, fractions, I can put this rule down here, okay? If I wanted to kind of add this to my notes here, that is, it is to multiply by the reciprocal of the second fraction. Okay, that is my rule. Did I spell that wrong? Okay, reciprocal. So I'm going to just add that to my notes there. That's my rule here. That when we're multiplying, when we're dividing, we multiply by the reciprocal of that second fraction. So please add that to your notes, that when I'm dividing, multiply by the reverse of the second. Okay. So let's go ahead and tackle a couple of these. I'll show you what it would look like. Let me model it for you. I've got 1/2 divided by 1/8. So what I would do is like this. I would write equals 1/2 times, okay, that's the multiply here. Okay, I'm going to write a little arrow here to point out that that's what I just said I was going to do, multiply, times the reciprocal of the second number, which I have 1/8. So now it's going to become 8/1. Okay. And then that I can go ahead and proceed with that and go, oh, these cross cancel. 2 goes into itself once, 2 goes into 8 4 times. This becomes 4/1, which equals 4. Okay. So what does that actually mean? If I divided 1/2 by 8, it goes into it 4 times. Okay. Why does that just seem funny to me? It just does. All right, moving on to the next one. Okay. You probably on your own could now do number 2 here. But again, I want to model it for you. Okay. I've got 3/5 divided by 5/8. So I'm dividing this fraction into this one. So what I'm going to do is I'll write an equal sign on my notes, my paper, and I'm going to write 3/4 times the flip, the reciprocal of 5/8, which becomes 8/5. Okay. And then at that point, I now have the option to now cross cancel. 4 goes into itself once, into 8 twice, multiply, and I get 6/5. Change it to a mixed, and it's 1 1/5. Okay. So that's the idea. Now, you'll notice on this number 3 here, we've got big numbers here. And that's again why you're going to find that cross canceling will become your friend. So again, I would write 14/15 times the reverse, which becomes 27 over 16. And I don't think I'm going to finish that for you, but I will tell you that I would say, well, 3 goes into both of these, okay? And 2 goes into both of these, so I can cross cancel down. Okay, that kind of gets you going on that. All right, hopefully that's somewhat clear. It's just multiplying by the reciprocal of the same number. Here, you probably at this point, after hearing how to handle this with just straight multiplication of fractions, you probably think, I think I know how to do this already. All I would do is go like this. And then I would write 3 over 1 times the reverse, which would be 4 over 3. And I would proceed from there, okay? Again, just put the whole number over 1, put the whole number over 1, and then proceed like you just learned, okay? So it's the same principle in multiplying and dividing fractions. And by the way, yeah, okay, so let's move on. Now, and again, it'll be the same idea here, okay? In case you're wondering, well, what if I'm dividing the fraction by the whole number? Is that any different? No, I'm just going to put it over 1, and then I would rewrite the equation like this. 3/4, that's the first one, times the reverse of 2 over 1, which is 1 over 2, okay? And then I would proceed from there. Again, second one, put it over 1 equals 8/9 over 1 over times 1 over 6. Okay, I think you have the idea. Let's go on to something a little bit more advanced, okay? Which is mixed numbers. What do we do with mixed numbers? Okay, so dividing, you could just write in your notes, dividing mixed. Okay, what do I do with mixed? And I'm going to give you about, I don't know, about 40 seconds here to go ahead and copy down what you see on the screen, and then we'll continue. Okay, we're going to jump in here. When we're multiplying and dividing fractions, it's that same rule. We can't work with mixed fractions. They just mess everything up. And so we're going to change it to an improper, just like we did with multiplying. So I would take 2 1/3, and I would say to myself, okay, 3 times 2 is 6, plus 1 is 7. This becomes 7 over 3 times, remember what you do here? Do you remember what to do here? Flip it upside down. That's called the reciprocal. And then I would proceed from there, okay? Likewise, with number 2 here, I've got a mixed fraction. 1 times 2 is 2, plus 1 is 3 over 2 times the reciprocal of this, which is 4 over 3, okay? All right. Let me jump to number 4 here just to see. I have 2 different mixed fractions. Now I want you to walk, maybe slow down a little bit for this one, okay? So we don't skip any steps. 2 times 4 is 8, plus 1 is 9 over 2. I'm gonna write a 9 here. Over 2, I'm gonna just write divided by again, just, and then I have 6, 1 times 6 is 6, plus 1 is 7 over 6, okay? All right. Now what I've done is turn these 2 mixed into 2 improper. Now I can proceed just like I would normally. I can go equals 9 over 2 times the reverse of this one right here. This is the second fraction, becomes 6 over 7. And in this case, I see it right away. These 2 cross cancel, these 2 don't, but that's how I would proceed from there, okay? So when you're multiplying and dividing fractions and you get mixed numbers in there, turn them into improper, then proceed, okay? Now, I want to say this one more time. This rule, put it in your notes here, this rule here, that when you're dividing, I want to really hammer this home here, this rule here, when you're dividing, okay, you got to multiply by the reciprocal. All right. Because it's that reciprocal of that second fraction. I've had many people on tests, get to this point in the midterm, and they were doing great on adding fractions and great on subtracting fractions and pretty good on multiplying fractions. Then they got to the page that was dividing fractions, and they treated it just like they were multiplying. They forgot to multiply by the reciprocal of that second number, and they missed every single one, okay? I don't want that to be used. So that's why I'm double emphasizing that that rule, when you're dividing, it's got to be the reverse of that second fraction. Okay. Let's take a look at a couple story problems to put it in the context of a story problem to do with division. Laura purchased 2/3 of a yard of ribbon in order to make bows. Each bow takes 1/6 yard of ribbon. How many 1/6 yards of bows can be made? All right. So again, I'll model for you this. She purchases her total purchase. This is how much she bought. She bought 2/3 of a yard. Okay. This is her total that we're now dealing with. This is the total, the big number. Okay. And each bow takes 1/6 of a yard. So how many of these 1/6 yard of a yard bows can she make if she has 2/3 of a yard total? Okay. So, okay, she's got 2/3 of a yard. That's her total amount right here. Okay. I'm just going to draw a little arrow here to say that's where that number came from. Okay. And that's going to be divided by this other number here, right here, 1/6. Now, if you're thinking, how come that's the case there? Okay. Because each bow she makes takes 1/6 of a yard. And they want to know how many of these, if each bow makes, each one takes this much, how many can she make if she has 2/3? So it's really just 2/3 divided by 1/6. And again, I'm going to write this out for you. Okay. This would become 2/3, I won't finish it, times the reciprocal of this number right here is now going to be 6/1. And I'll proceed from there, cross cancel and continue. Okay. All right. Let's take a look at another one here. If a tortoise is time traveling an average of 1 2/3 miles per hour, it seems pretty fast for a tortoise to me, but maybe I'm wrong. How long would it take the tortoise to travel 6 miles? Okay. Now here's a little hint, a little clue here. Because I know here's the numbers. I know I got the number 6. Okay, I should change color here real fast. I got the number 6 here. And I got the number 1 2/3. Okay. And so some students might be thinking, well, which number do I divide into which? Which one goes on the left and which one goes on the right? And here's a hint. Almost every single time, what number do you think would be on the left? The bigger number, because you're always dividing the smaller number into the bigger number. Okay. So I've got 6 miles. So this is that example where I've got 6 divided by, okay, and then this other number here, which is this 1 2/3. So it's 1 2/3. Okay. Now, what I would do, the first thing I would do at this point is I would take my 6 and put a 1 underneath it. So I'm thinking like a fraction. And then what I would do from here is I would go, okay, this is really going to equal 6/1 divided by, I'm just going to write out all the steps and not skip any here. Okay. I'm going to change this mixed. 3 times 1 is 3, 4, 5. This is 5/3. Okay. And then that equals, okay, just like I taught you, see, this is 6/1 divided by 5/3. 6/1, write it on your notes and your paper. Okay. 6/1 times the reciprocal, the reverse of that second number, which is now going to be 3/5. And here I can proceed from there, okay, which is going to give me 18/5, which gives me 3 15 3/5. Okay. All right. All right. So that is everything we needed to know. And we finished in less than an hour on how to multiply and how to divide fractions. So I hope that's helpful. And again, if you have any questions for me, if you run into some questions, be sure and shoot an email to me, and I'm sure you'll start getting this real quickly. Okay. All right. Give me just a second here as I attempt to. There it goes. Stop.